Okay, now we want to look at a quantity called the difference quotient. We look at it here in college algebra to begin the calculations. It becomes very important to us when we get to calculus. In calculus, we try to figure out how to use the word slope with curves other than lines. So right now, we know how to find the slope between 2 points along a line. And in calculus, we talk about slope along a curve. Okay, and so to begin to do that, right, we take a general function, y equal to f of x. Could be a quadratic function, rational function, any kind of function. And then we're just going to pick 2 points along that curve. One will have input x, and then the other one will have input x plus h. Okay, so the points, remember the x, so the first input is x, plug it in, the output will be f of x. Second point, we're going to input the quantity x plus h. So again, the output will be f of x plus h. Okay. So we use our slope formula, using this as x1 and x2. Here's your y1 and y2. Okay. And so we just calculate slope as the y2 minus y1 over x2 minus x1. Okay. And then the only thing we clean up is in the denominator, you have an x plus h minus x. So the x is summed to 0, and you're just left with h. So this quantity here is referred to as the difference quotient. It will give you slope between 2 points along any curve. All right, so we're going to calculate that a couple times. Keep in mind there's 3 pieces to this. The denominator is sort of the easiest piece. It's just h. The numerator needs the function evaluated at 2 different places. Once at x, which is pretty quick, the other one at x plus h. All right. So again, we want to make this calculation. We want to find the difference quotient for our first function here, f of x equals 2x plus 1. Okay. Again, what I would say to do is maybe off to the side here, calculate your f of x plus h first. It's the first piece you need, and it's the most difficult one of this quantity. Okay. Again, keep in mind, we're typically given functions in this form, and we typically read this as f of x equals 2x plus 1. Okay. But again, a function does things to inputs. So in this case, any input, what does this function do? It'll double it and add 1. Okay, so again, the way we write it shows us what it does to x. It takes twice x and adds 1. But we would know if we plugged in 7 to this function, we would get twice 7 plus 1. Any input will get doubled and then 1 added to it. So if I want to input x plus h, again, this f function in our example doubles it and then adds 1. Okay. Again, I'll just clean this up over here. I'll distribute my 2, and there's no like terms. Okay, so again, this is the first piece I need in the numerator, and oftentimes I'll work this out over to the side. Okay. And so for my difference quotient, f of x plus h minus f of x over h, I have my first piece now, which is the 2x plus 2h plus 1, minus the second piece, which is f at x, and again, that's typically the way the function will be given to you, all divided by h. And now it's just a matter of cleaning it up. Okay, so again, I'll remove the brackets on top. So 2x plus 2h plus 1. Make sure you distribute the minus sign here. So over h. Okay. Typically there will be a little bit to reduce up on top, so we have a positive 2x and a negative 2x. We have a plus 1 and a minus 1. Okay. So that will leave us just with one term on top, 2h over h. Okay. And then finally we can cancel the h's, we'll have 2. Now again, this is normally where you write h cannot be 0. Okay, now that our h is not in the denominator, up here we know h can't be 0, so those should not be 0 down here. Okay. It's also nice that we want to put 2, because we know this is a linear function. This is supposed to be a slope calculation, and we did in fact get 2. Okay, so now let's take a look at one that is not a linear function. So we'll move up to a quadratic. So again, we're going to calculate the difference quotient and we're getting this quadric x squared minus 5. The three pieces we need, keep in mind we're using G here, we need to plug in x plus h, plug in x, which is kind of already done for us, and then our denominator is h. So again, off to the side here, I'm going to calculate g of x plus h. And again, it's important when you read this function, it will typically be given as g of x equals 3x squared minus 5, but again, try not to use the word x, because now you're not plugging in x anymore. So describe in words what this function does. Any input will be squared, then multiplied by 3, and that result then subtract 5 from it. Okay. Any input will be squared, then multiplied by 3 and subtract 5. So if I'm going to plug in x plus h, it will get squared, it's going to get multiplied by 3, and then subtract 5. And then again, I'll take some time here to clean it up. So I FOIL out, multiply out that parentheses, so that's x squared plus 2xh plus h squared minus 5, and then distribute my 3. So 3x squared plus 6xh plus 3h squared minus 5. Again, no like terms, so I'll just leave it like this. Okay, that's the first piece I need. It's the messiest piece, but now I have it worked out. Okay. So for my difference quotient, I will get my first piece, the function evaluated x plus h, which I now know to be 3x squared plus 6xh plus 3h squared minus 5. Minus the second piece on top is your function at h, at x, so that's 3x squared minus 5, all over h. Okay. And remove the parentheses on top, so I have 3x squared plus 6xh plus 3h squared minus 5. Distribute your minus sign, so minus 3x squared plus 5 all over h. Again, you would expect a few terms on top to combine, so I have a positive 3x squared and a negative 3x squared, and then my minus 5 plus 5. So I'm only left with two terms on top, the 6xh and the 3h squared. I'll go ahead and factor. So I can take a 3h on top, leaves me with a 2 and an x from the first term and an h from the second term over h, and now I can cancel those, and I get 3 2x plus h. And again, I'll just note here, h started out in the denominator, so h should not be 0. So our difference quotient here would be the quantity 3 times the quantity 2x plus h.